Okay guys, so today we're going to go ahead and we are going to be graphing rational functions, but this is going to be a little bit more detailed and taken to the next level from the one that we did previously in this lesson. This is going to be very, very, very helpful when you guys go to pre-cal or even calculus. This is going to be like super duper important. Not every single graph is going to be the same. They're going to be different. But you should be able to just follow these steps right here that I put here on the side. And that should definitely be able to help you out. And then if you forget, like, let's say how to find a vertical asymptote or horizontal asymptote, or how to find the zeros and things like that, then just go back to the previous lessons, because all of this is based off of the previous lessons that we learned. So the first example that you're going to get is g of x equals x squared minus 2x minus 3 divided by x minus 2. So if we follow the steps, first thing it says, factor the numerator and the denominator of the function. So we have to factor these. Now, if you look at this, the denominator is already factored, so you don't have anything to do there, but we do have to factor out the numerator. So I'm going to get two binomials with x minus 2 in the bottom. X and x, with the only numbers that multiply to 3 are 3 and 1. I want to have a negative 2 right here. So that means that the 3 will be negative and the 1 will be positive. Okay, so I'm going to get g of x equals x minus 3 times x plus 1 over x minus 2. Okay, that was step 1. Step 2 says to identify discontinuities, meaning vertical asymptotes and holes. Okay, now remember, vertical asymptotes, these come from the denominator. Okay, let's put this here. They come from the denominator when you get it to equal to 0. Okay? And then the holes, those come from canceling common factors, right? Which, if you look at the equation, you have x minus 3, x plus 1, x minus 2. There's no common factors. So will we have any holes in this one? There will be no holes. So for the holes here, we can say that there's going to be none. Okay? Now for the vertical asymptote, well, for the vertical asymptote, all you have to do is get your denominator equal to 0. So that's x minus 2 equal it to 0. Add the 2, x will equal to 2. So my vertical asymptote is going to be at x equals to 2. Okay? Now let's move on to step number 3, which says identify the intercepts and other applicable points. So that means finding the x and the y intercepts. Okay? So we have to go ahead and find the x-intercept and the y-intercept. Now, just remember that the x-intercepts, okay, you get those from the numerator. And getting the numerator to equal to 0, okay? Okay, and then for the y-intercept, well, all you have to do is just make the x values equal to 0, okay? So in this case, I'll get my numerators, which are these right here, and set both of those equal to 0. So that means that I'm going to get x minus 3 equal to 0, and then x plus 1 equal to 0. Add the 3. X equals to 3, subtract the 1. X equals to negative 1. So my x-intercepts will be 3, 0, and negative 1, 0. Remember that you have to put them in this format, guys. Okay, they're not just lines. Okay, if you put x equals 3, x equals to -1, I will take points off because you're stating them to be lines. Intercepts are points, so you have to put them in 3, 0, -1, 0. Now, you can also call these x-intercepts, you can also call them zeros. Okay, guys, so just keep that in mind. Now, for the y-intercept, we're going to get the original function and then just replace every x with 0. Okay, so now we're going to go ahead and get, you can either use the original or the factor form, whichever one you want. I'd rather just use the original one. So y is going to equal 0 squared minus 2 times 0 minus 3 divided by 0 minus 2. 0 squared is 0, 2 times 0 is 0, minus 3, 0 minus 2 is -2, so then that'll give me -3 over -2, which is just 3 over 2, because a negative divided by a negative is a positive. So my y-intercept is going to be 0, 3 over 2. Okay? Now the next step says to divide up the domain into intervals based on when the function is equal to 0 and when it is undefined, aka has a vertical asymptote. So, domain, you basically just have to include the restrictions. Now I'm going to use set builder notation, so that I'm going to say I want the x values such that x cannot equal to 2. Because this right here is the only discontinuity that I have. So I'm just going to say x cannot equal to 2. Other than that, it'll be every single other value. Now, for the range, that one's easy. Because do we have a horizontal asymptote here? Well, for the horizontal asymptote, let's check it out. Right? We get the highest degree in the numerator and the highest degree in the denominator. So here it's a 2, and here it's going to be a 1. So that's what I have. So I'm going to have 2 over 1, which means that m is going to be greater than n, okay? And if m is greater than n, that means that there is no horizontal asymptote. So therefore, I'm not going to have any limitations on my range, and I can just say that it's going to be all real numbers, okay? Next step. And I memorized this rule right here. So if you guys don't memorize it, it was in yesterday's lesson. Okay. Next one, we want to use test points in each interval. So step 5, to see whether the function is going to be positive or negative. Now this right here, this is going to be the new lesson for today. How do we use test points to figure out if it's going to be positive or negative? Okay, and then we're going to go ahead and plot the points and connect according to sign intervals. So, okay, so now let's go ahead and continue with step 5. Now for step 5, I'm going to go ahead and I'm going to use red pen. Okay, now what step 5 is called, this is called a sign chart. Okay, so what you're gonna do is you're gonna go ahead and create a sign chart, and we're gonna use these x-intercepts right here. Okay, I also forgot to mention here, horizontal asymptote, there is none. Okay, because we did that right there. But let's go ahead and remember what the equation was, right? So we got x minus 3, x plus 1. Divided by x minus 2. Okay, so let's go ahead and create the sign chart. And we're going to use our x-intercepts, right? So -1 and 3. Okay, now the reason why this is called a sign chart is because you just, like it says here, you just want to know if things are going to be positive or negative. So you're not going to have to do like the actual math of like adding and subtracting numbers and seeing what the final value is. But we just want to know whether things are going to be positive or negative. That is why it is called a sign chart. Okay, now what we have to do here though is we do have to pick values that are going to be greater than or less than in this situation. Okay, now there is another value that we do have to include, and that is going to be this vertical asymptote right here, because it is going to be a line that we are going to have to graph around, because it is going to be an asymptote, right? So when you're doing a sign chart, include your vertical asymptotes and your x-intercepts, so that way that you can so you can find this correctly. So what you have to do now is you have to pick values that are greater than and less than between all of these values. So if I see this -1, I have to pick a number that's less than -1. You can pick whatever number you want. It does not matter. It just has to be less than -1. So I'm going to go ahead and I'm going to pick, let's say, -2. Now what I'm going to do is that this -2 is going to be substituted into the equation over here. So I'm going to have -2 minus 3, -2 plus 1, and then -2 minus 2. Okay? And I don't care about the math, guys. I just care to know if these are positive or negative. So I'm going to have a -2 minus 3, which is a -5, times a -2 plus 1, which is a -1, divided by a -2 minus 2, which is going to be a negative number at the end of the day. But now a negative times a negative is going to be a positive. So now I have a positive divided by a negative, which a positive divided by a negative at the end of the day is going to be a negative. So on the left side of -1, I'm going to have negative values. Okay? And so now we have to pick a number between -1 and 2. And I'm going to go ahead and I'm going to pick 0. Okay. So now I'm going to have 0 minus 3, 0 plus 1, and then 0 minus 2. Well, what's 0 minus 3? 0 minus 3 is a negative number, and then 0 plus 1 is a positive 1. So I'm going to put times a positive divided by 0 minus 2 is a negative. So a negative times a positive is a negative, and then divided by a negative. So now a negative divided by a negative is going to be a positive. So anything between -1 and 2 has to be positive. Okay, guys? And now we have to pick something between 2 and 3. Obviously, there is no whole number between 2 and 3, so you do have to pick a fraction. So I'm going to go ahead and say I'm going to pick 2.5. So I'm going to get 2.5 minus 3 times 2.5 plus 1 times 2.5 minus 2. So 2.5 minus 3 is going to give me a -0.5. And then 2.5 plus 1 is going to give me a positive. 2.5 minus 2 is still going to give me a positive. So I'm going to have a negative times a positive, which is a negative, divided by a positive, which at the end of the day is going to give me a negative. Okay, and last but not least, I need something that's greater than 3. We can go ahead and pick, let's say, 4. So I'm going to get 4 minus 3, 4 plus 1, and then 4 minus 2. So what's 4 minus 3? That's a positive. 4 plus 1, that's another positive. And then 4 minus 2 is a positive. So positive times a positive divided by a positive is just going to be a positive. So if you guys want to see the sign chart a little bit clearer, right, we can do it again over here. You're going to have a -1, 2, and a 3. Anything that's less than -1 has to be negative. Anything between -1 and 2 is going to be positive. Anything between 2 and 3 is going to be negative. And 3 and greater has to be positive. Okay? So now let's go ahead and put all of this information together and let's create this graph. Okay? So I'm going to go ahead and get a graph right here. And we're basically just going to start graphing all the information that we found up here. So holes, do we have any? No. Okay, so check on that. And now vertical asymptote, yes, we do. It's going to be at x equals to 2. Okay, so I go to x equals to 2, 1, 2, and I draw my vertical asymptote. Okay, and that's my vertical asymptote at x equals to 2. Okay, now here we have x-intercepts, okay, and these x-intercepts are going to be at 3, 0 and -1, 0. So I'm going to go to 3, 0, 1, 2, 3, draw my x-intercept. I'm going to draw it pretty big so that way it stands out, and then at -1, 0. And that's my other x-intercept right there. Okay, so we already drew those. My y-intercept is going to be at 0, 3 over 2. Y-intercept 0, 3 over 2. So let's say that's 1. So 3 over 2. Well, 3 over 2. I'd say that's 1, and then that's 2. So 3 over 2 is literally 1.5. So I'll put that one right there. Okay. The domain, well, that's just going to tell me what it's going to be. And my range is all real numbers. Horizontal asymptote is none. So now, what is this going to look like? Well, this is what the sign chart is for, right? So here, anything that's less than -1 has to be negative. So where do I have my -1? Right here. So anything that's less than that or left to the -1 has to be negative. Therefore, that means that that is going to be going downwards like this. Okay? That's what that part tells you right there. It's going to be going downwards. Okay? So that's what the sign chart is used for. The sign chart is going to tell you what these functions are going to look like. So now anything between -1 and 2 has to be positive, meaning that it has to go up, right? So anything here between -1 and 2 has to be positive. So what is positive? Well, going upwards, but notice it still has to be connected to the -1, so it's going to go upwards. But make sure that it also crosses the y-intercept. So if I do that, it'll go, let me fix this a little bit. So you can cross the y-intercept and then go upwards. Okay? It looks a little bit funky, but you guys can make yours look a little bit better. So it goes like that. Now, do notice that I do make it approach the vertical asymptote because it's not going to touch it. It's just going to infinitely approach it. So therefore, it looks something like that. Okay? And now, anything between, let's see, between 2 and 3 has to be negative, right? So what I'm going to do is that I'm going to go to the 3 because that's my x-intercept right there. And between -3 and 2 and this being 2, it has to be negative. So that means that this one has to go downwards right here. Okay? Because that's negative, going down. Okay? And then anything 3 and greater has to go up. So this one goes up like that. And that right there is what the function looks like. Okay, guys? And I'm just going to go ahead and leave it at that. I want you guys to review this information. I'm going to give you guys more examples tomorrow. I just want this to settle in and kind of think about it. But that's what we're going to do because not every single graph is going to look the same. You're going to see in the next 2 examples that we're going to do. But this is going to be important skill. So basically all we're doing is bringing everything that we've learned the past couple of days together into one lesson with the minor new introduction of the sign chart right here, which I will go ahead and try to explain a little bit more in the next 2 examples. But if you guys have questions, just let me know. Okay? Have a good one.